Welcome to a presentation brought to you by the American Wood Council. Thank you for your participation in our webinar today. This webinar is intended to provide general information only and does not constitute professional or engineering advice. Please note that this webinar is being recorded, and by remaining a participant, you automatically consent to such recordings. If you do not consent to being recorded, please disconnect from the session. This presentation is worth 1 LU HSW with the AIA and 0.1 credits with the ICC. To receive credit for the course, you must attend this webinar for a minimum of 50 minutes. At the end of 50 minutes, you will see your certificate appear on your webinar console. Your certificate will also be uploaded into your learner profile on learn.awc.org, provided you registered for today's webinar with the same email address as your account profile. At the end of today's session, our presenter will have a live Q&A with the audience. Please input your questions into the Q&A panel throughout the session. And now, for today's presentation.
All right, welcome to everyone here in our audience, and thank you for having us. Speaking on behalf of myself and my colleague Ed Lazinski, it's an honor to be able to present to you today. As was mentioned, I'm Jason Smart, Director of Fire Engineering at the American Wood Council, and I'm co-presenting this webinar with Ed Lazinski, who is our Midwest Regional Manager here at AWC. Today we're going to talk about fire resistance ratings and sound ratings for wood frame assemblies. We'll talk about the building code requirements, code recognized ways in which to demonstrate compliance with those requirements, and some of the resources that can be used to facilitate design which meets these requirements. Please note that this presentation is copyrighted and reproduction without permission is prohibited. Please note that this webinar and associated slides provide pertinent information regarding the design of wood structures, but they should not be used as a substitute for competent engineering and expertise. Here's the basic course description for this course. I think you've all seen this description already in the materials that you previously received when you registered for the course, so we'll just go ahead and skip straight to the learning objectives. And here they are. The learning objectives for this course are listed here, and you can see that under the heading titled Sources of Fire Resistance Ratings, we'll learn about how fire resistance ratings are derived and how they're used in building codes. And then as far as code requirements go, Ed is going to take us briefly through the model building code requirements that apply to fire resistance rated wall and floor wall intersections in type 3 construction. And we'll examine critical details in these assemblies. Then we'll explain the types of fire resistance rated assemblies described in DCA 3 and how that information can be used to demonstrate compliance with code requirements. And then fourthly, Ed and I will both talk a little about sound transmission ratings in buildings. Ed's going to talk about the code requirements regarding sound transmission performance, and I'll explain how the DCA 3 document again can be used to demonstrate compliance with these performance requirements. One thing that I wanted to mention to get us started off here is that reference standards become part of the code, at least to the extent that their content is within the scope of the charging language in which the standards are referenced in the code. So when dealing with the International Building Code, for example, Chapter 35 is the chapter that contains the list of all the standards that are referenced within the code. This includes the title of the standard, the agency writing the standard, and the applicable edition of the standard by year. Code reference standards represent consensus on how a material, product, or assembly is to be designed, manufactured, tested, or installed so that it achieves a specified acceptable level of performance. Several key standards relating to design of wood structures are utilized by the IBC. Specifically, the 2024 IBC references the 2024 ANSI AWC National Design Specification for Wood Construction, or NDS, along with its supplement. Also referenced in the 2024 IBC are the Wood Frame Construction Manual, that's the 2024 version, the 2021 edition of the Special Design Provisions for Wind and Seismic, the 2021 edition of the Permanent Wood Foundation Design Specification, and also the 2024 version of the span tables for joists and rafters. all of those AWC publications. And then also more recently added to the AWC family of standards is the 2024 ANSI AWC Fire Design Specification for Wood Construction, or FDS. The FDS is a valuable resource that we'll talk about later in this webinar for fire design. All of these standards are viewable online at AWC's website for free view. Since you're here for this webinar, I presume you either have some idea of what DCA3 is or you'd like to learn more about it. So that's what we'll talk about. DCA3 is part of a series of AWC publications called the Design for Code Acceptance Series, or DCA series. It can be accessed and downloaded for free along with any of the other DCA documents in this series on the AWC website. DCA3 deals specifically with fire resistance ratings, sound ratings, and example details for light frame wood assemblies. It provides fire resistance data for tested wall assemblies and floor ceiling assemblies. It provides sound insulation data for floor ceiling assemblies, and it provides example details for exterior wall floor intersections in Type 3 platform construction. We'll talk about each of these in more detail later in this webinar, but first Ed Lazinski will give us an overview of the code provisions pertaining to these topics. So Ed, over to you.
Thanks, Jason. My name is Ed Lazinski. I'm the Midwest Regional Manager for the American Wood Council, and I'll talk to you about some of the codes and the defined terms that are applicable to the DCA3 and to fire resistance in general. We'll also talk about sound resistance as well in this portion. So first we'll start off with some definitions. The first one on there, fire resistance, which is that property of materials or their assemblies that prevents or retards the passage of excessive heat, hot gases, or flames under conditions of use. So keep in mind when we talk about fire resistance, that's a property of that material or that assembly, again, to slow down or prevent the passage of fire. Fire resistance rating, when we talk about that, that's actually a period of time. A 1 hour wall, a 2 hour protected column, things like that. So fire resistance rating is defined as the period of time a building element, component, or assembly maintains the ability to confine a fire, continues to perform a given structural function, or both, as determined by the tests or the methods based on the tests found in section 703. So we'll talk about each of those quite a bit throughout this presentation. There's a few other terms that we're going to talk about. So approved means acceptable to the building official. Anytime you see the word approved in the building code, the building official has the final call on that, whether or not that's acceptable or not. An approved agency is an established and recognized organization that is regularly engaged in conducting tests, furnishing inspection services, or furnishing product evaluations or certification where such an organization has been approved by the building official. So an approved agency, again, that's a defined term in the code, but that's going to talk about a company or an organization that is conducting tests and doing product evaluations. An approved source can be just about anyone. That's an independent person, firm, or corporation, again, approved by the building official, who is competent and experienced in the application of engineering principles to materials, methods, or system analysis. So an approved agency is a company or an organization that's doing the tests and doing the product evaluations. An approved source can be any person, any firm, any company out there, just somebody that's experienced in applying engineering principles to those systems. And then also fire retardant treated wood. That's wood products that, when impregnated with chemicals by a pressure process or other means during manufacture, exhibit reduced surface burning characteristics and resist propagation of fire. Keep in mind, fire retardant treated wood does not mean that it is a non-combustible material. It's still wood, it's still a combustible material, it's still going to burn. It just slows down that surface burning characteristics and resists expanding that fire. So one other term, it's not defined in the IBC, but we're going to talk about it quite a bit here when we talk about the DCA3, and that's wood frame construction. So we just put out a little definition here of what we mean when we talk about wood frame construction. And that's a general term used to describe construction in which the primary structural system consists of repetitive wood members and assemblies. So you think about platform construction, where you're going to build your first floor walls. You're going to have some floor joists that come over and bear on top of that first floor wall. On top of that, you're going to build your second floor wall. There's going to be, again, some floor framing that comes in, bears directly on top of that second floor wall, and then you're going to have, potentially a third floor, or however large your building is. But we're looking at that platform construction, that wood frame construction. We're using repetitive members, wood studs in there, wood floor joists, wood trusses or rafters up above for the roof. All right, so first let's talk about fire resistance. Again, that's that property that we talked about of a material. Section 703.2, fire resistance. The fire resistance rating of building elements, components, or assemblies shall be determined in accordance with section 703.21 or 703.2.2. Now also, it also gives you a third option there of in accordance with section 703.2.3. We'll take a look at all three of these in just a second. So section 703.2.1, a fire resistance rating of building elements, components, or assemblies shall be determined by the test procedure set forth in ASTM E119 or UL 263. So if you want to come up with a fire rated building element, such as a wall assembly, you can go out, you can have it tested to ASTM E119 or UL 263. They'll provide you a test report on that, and you can walk in and say, this wall assembly that I created has a fire resistance rating of 2 hours, for example, or whatever the testing shows. So that's your first option in the code, is go out, get it tested, whatever assembly that you have, and you have that test report that's going to show how much fire resistance rating you have for that building element. The second option in the code displays several analytical methods found in 703.2.2 that says the fire resistance of building elements, components, or assemblies established by an analytical method shall be any of the methods listed in this section. So option 1, fire resistance designs documented in approved sources. Now we just talked about approved sources in those defined terms. And again, that's any independent person, firm, or corporation approved by the building official, because we have that approved word in there, who is competent and experienced in the application of engineering principles to materials, methods, or systems analysis. So somebody that understands what they're doing, they're competent, they're experienced, they can come up with a fire resistance design. But again, it has to be accepted by the building official. Option 2, prescriptive designs that are found in the code in section 721. If you've ever flipped through chapter 7 of the IBC, you've probably seen pages and pages of prescriptive designs for building elements in there. You can take any of those. Those are perfectly fine for establishing fire resistance as well. Your third option in the analytical methods is calculations in accordance with section 722. 722 is going to get into a whole bunch of different material-specific methods for calculating fire resistance. The one that we're most, interested in with wood construction here is section 722 does have a reference to the National Design Specification for Wood Construction, or the NDS, which is a document that AWC produces. Jason mentioned that earlier in some of the introductory slides. But again, any other material is also out there as well. The fourth analytical method is engineering analysis based on a comparison of building element, component, or assembly designs having fire resistance ratings as determined by test procedures set forth in ASTM E119 or UL 263. So you can have an engineering analysis performed possibly by an approved source that's going to compare a building assembly to one that was tested by ASTM E119 or UL 263. So you can compare those two and you can say, yep, I didn't get this one approved or tested, but here is a tested assembly, and I've gone through the engineering analysis to prove that these are going to be compatible with each other. And then the fifth analytical method is fire resistance designs certified by an approved agency. And again, we saw the definition for approved agency as an established and recognized organization that is regularly engaged in conducting tests, furnishing inspection services, or furnishing product evaluations. So again, there's many different approved agencies that are out there. Some are maybe more common in your region than others, but those are perfectly fine as well to use. Now there was that third method mentioned in section 703.2, and that was approved alternate method, or the approved alternate method. And that states that fire resistance of building elements, components, or assemblies not complying with 703.21 or 703.22, and again, that's the testing or the analytical methods, shall be permitted to be established by an alternative protection method in accordance with section 104.2.3. And I'm sure everybody's very familiar with 104.2.3. That's your alternative materials, design, and methods of construction and equipment. Now in the 2024 code, this section got changed a little bit and moved around, but the basic premise is still there, right? You can, as the building official, you can approve any alternative material or design or method of construction as long as they show that equivalency to the code. So that still is an option for you as well. So we talked about what fire resistance is and how you can establish it, but where do you actually use fire resistance? On the screen right now are all the different options in the code of building components that may need to be fire resistance rated. Now, not all these have to be fire resistance rated all the time, but if something does have to be fire resistance rated, it's going to come off of one of these items in the list. So the first one on the list there was table 601. So this is fire resistance rating requirements for building elements. This is a table that I'm sure everybody's very familiar with. This goes through the different building elements and then the different types of construction and what fire resistance rating, what time and hours you need to protect each of those elements. Now keep in mind, building element is a defined term in the IBC, but basically what that definition tells you is that a building element is any of the structural elements that you find in this table. So your primary structural frame, your bearing walls, your non-load bearing walls, your floor construction, and your roof construction. That's what establishes or makes up the building elements. So for example, in using this table, if you start into the upper left-hand box there, a primary structural frame on a type 1A building is going to be 3 hours. If you go to the lower right-hand corner, the roof construction of a type 5B building is going to be 0 hours. And you have different elements requiring different fire resistance ratings throughout that table, anywhere from 0 hours to 3 hours. You'll notice in that last table, I should have mentioned this on the last table there, but exterior walls, it actually refers you over to table 7055. We'll look at that a little bit later on. But that table is found in the exterior wall section. So exterior walls possibly have a fire resistance rating to them. They have different unique structural and penetration requirements. You have anywhere from 0 to 3 hours on your fire resistance rating of an exterior wall. And something to keep in mind, anytime that your fire separation distance is 10 feet or less, your fire separation distance is determined by the distance between your exterior wall and a property line, a lot line, the center line of a street or a public way, or an imaginary property line between two buildings. Anytime your fire separation distance is 10 feet or less, you're now worried about fire exposure from both sides of that wall. Otherwise, under normal conditions, you're just worried about fire starting inside the building and burning its way out. Once you get closer to a property line or another building, you're now worried about a fire originating in that building and working its way into your building. So actually where that section comes from is in 7055, fire resistance ratings of your exterior walls. And you can see in the darker section there, the required fire resistance rating of exterior walls with a fire separation distance greater than 10 feet shall be rated for exposure to fire from the inside. The required fire resistance rating of exterior walls with a fire separation distance of less than or equal to 10 feet shall be rated from exposure to fire from both sides. We'll see how that works in a little bit in the DCA 3 when Jason goes through some of that part. Any interior element has to be rated on all sides from that fire as well. So, if you have an interior wall that we'll see a little bit later on, you have to worry about fire exposure from both sides of that wall on an interior wall. This only comes into play on exterior walls where you're worried about that fire separation distance. IBC 706 talks about firewalls. Firewalls are going to take one structure. If you put a firewall down the middle of it, you now have two separate buildings. So a firewall creates a separation and creates actually two separate buildings. So that's going to have some unique structural and continuity requirements. When you get into 706, both sides of that firewall have to be structurally independent from each other, so that one side of that building or that firewall or that separate building can collapse and get burned out, but that firewall is going to maintain structural integrity, as is the building on the other side of that firewall. They always have to be constructed of non-combustible materials, with the exception of Type 5 construction. You can use wood-framed firewalls in Type 5 construction. And then the rating requirements are based on the occupancy of that building, so anywhere from 2 hours to 4 hours. Fire barriers are sort of the next step down, and those can be found in IBC 707. They're going to create fire-resistant separations within that building. And again, when you have an interior element like a fire barrier, now you're worried about fire exposure from both sides of that fire barrier, or that fire or any other ones that we have on the interior. So typical uses for these include shaft enclosures, exit enclosures, occupancy separations, exit passageways, fire areas, and they can be anywhere from 1 hour to 4 hours. Fire partitions are the next step down in IBC 708. Again, worried about fire exposure from both sides in a fire partition. These are typically your dwelling unit separations, tenant space separations, corridor walls, things like that. They can be anywhere from a half an hour to an hour. Floor and roof assemblies, those are going to be obviously separating out your horizontal spaces from each other, right? So anywhere that you have mixed use occupancy separations, fire areas, dwelling unit separations, things like that, anything that you need that separation through a floor, you're going to have a floor and roof assembly. And those can be anywhere from 0 hours to 4 hours. Now with each of those, when you get into each of those different sections, they're going to have pointers back to, typically have pointers back to 714, 715, 716. These aren't really addressed with the DCA 3, but I just wanted to, as long as we're talking about fire resistance, I just wanted to bring these up because they are very important to maintaining that integrity of the fire resistance rated assembly. So anytime that you're penetrating the membrane of that fire rated assembly, you have to look at your penetration protection, either through the membrane or through penetrations as well. Any joints and voids that are in there, and then also any protecting any openings that you might have in there, windows, doors, fresh air intakes, things like that are openings in those elements. We're going to switch gears now and talk about sound ratings. So sound ratings are found in Chapter 12 of the IBC, and they're going to apply to common interior walls, partitions, and also floor ceiling assemblies between adjacent dwelling units and sleeping units, so between one dwelling unit and the next, or between dwelling units and sleeping units and adjacent public areas. So there's two different types of sound transmission. You have airborne sound and you have structure-borne sound. We'll take a look at each of those as we go here. So 1206.2, airborne sound. Walls, partitions, and floor ceiling assemblies separating dwelling units and sleeping units from each other or from public areas again. shall have a sound transmission class of not less than 50 or tested in accordance with ASTM E90. So that's the STC rating is what you'll find on the next slide here. You need that STC rating of 50, and that's for airborne sound. So airborne sound includes things like amplified electronic devices, human voices, musical instruments, basically your neighbors playing their music too loud. The code's going to require an STC rating of 50, and again, that applies to walls and floors. Now, structure-borne sound is the other side of that, which talks about floor ceiling assemblies between dwelling units or between dwelling units and the public areas again within a structure have an impact insulation class or an IIC rating of not less than 50 or tested in accordance with ASTM E492. So again, STC, the sound transmission, that's for walls and floors. Impact insulation class, IIC, is just talking about floors. So that's going to be, somebody stomping around, objects being dropped on the floors, things like that. So that's that impact on the floor above you. So this would be your neighbor upstairs, running around, stomping around. You don't have that IIC rating on walls. You can have an IIC rating on walls, but the code doesn't require you to meet a certain IIC rating for a wall. So you can bang on the wall all you want to tell your neighbor to turn his music down if it's too loud. So with that, now we talked about the fire resistance rating, we talked about sound ratings. To bring all that stuff together and show you how that applies to the DCA3 document, I'll turn this back over to Jason to go through that document and see how all these tie together.
All right, well, now that Ed has taken us through the code requirements regarding fire resistance rated assemblies, sound transmission ratings, and how compliance with these requirements can be demonstrated, I'm going to talk about how DCA3 can be used as a resource in demonstrating this compliance. The fire resistance ratings given in DCA3 are in compliance with at least 3 of the code recognized methods for establishing fire resistance ratings. And specifically, these are the wall and floor ceiling assemblies described in DCA3 are tested in accordance with ASTM E119, first of all. And then secondly, DCA3 is typically considered an approved source. And thirdly, duplicate or very similar assemblies are prescribed in IBC section 721. So as you can see, the fire resistance ratings of the assemblies described in DCA3 are justifiable through multiple avenues that are allowed under IBC section 703. DCA3 provides descriptions of rated floor ceiling and wall assemblies. For the floor ceiling assemblies, DCA3 provides data on both fire resistance ratings and sound ratings. For the wall assemblies, it provides fire resistance ratings for both symmetrical and asymmetrical walls. In addition to these floor and wall assemblies, DCA3 also provides example details for common configurations of exterior wall floor intersections in Type 3 platform construction. Table 1 provides descriptions of 1-hour fire resistance rated assemblies. It includes a mixture of some symmetrical assemblies and some asymmetrical assemblies. The ratings for the symmetrical assemblies apply to exposure from either side, but of course not both sides simultaneously, as this would not be required by code. The ratings for asymmetrical assemblies apply to exposure from the interior side, which is the side to which the gypsum wallboard is applied. Table 2 describes a 2-hour fire resistance rated wall assembly, and this is a symmetrical wall assembly rated from either side. In both of these tables, there are embedded links that take the reader to detailed descriptions of each individual assembly. Also provided in these tables are cross-references to the corresponding assemblies in IBC Table 721.1 Parent 2 or Table 721.1 Parent 3. Here's a more legible excerpt from Table 1, which provides descriptions of the 1-hour fire resistance rated assemblies. This is not the entirety of Table 1, it's just an excerpt from it, but you can see that the embedded links are provided in the column with the heading titled Details, and these take the reader to the detailed description of that respective assembly. And then the cross references to the corresponding assemblies in the IBC prescriptive tables are provided in the rightmost column there of this table. So if you click on one of those links within Table 1 or Table 2, it'll take you to a page within DCA3 which looks like this and describes that particular wall assembly in more detail. Honing in on the symmetrical 1-hour wall assemblies, they all have a single layer of 5/8 inch Type X gypsum wallboard on both sides. That's for the symmetrical assemblies, that is. DCA3 lists 4 of these symmetrical 1-hour wall assemblies in all, and one of them is framed with 2x4 studs. The other 3 are framed with 2x6 studs at 16 inches on center. As far as insulation goes, one of these assemblies has fiberglass insulation and 2 of them have mineral wool insulation, and then the other one doesn't require any insulation at all. The one shown here on the right actually happens to be assembly WS4-1.1 of DCA3, and that's a 2x4 framed assembly with mineral wool insulation. Now it's important to note that all 4 of these symmetrical assemblies are rated under 100% design load. And then there are a total of 5 asymmetrical 1-hour wall assemblies in DCA3. 2 of these have 2x4 studs spaced at 16 inches on center, and 2 have 2x6 studs at 16 inches on center, and then one of them has 2x6s at 24 inches. All 5 of these assemblies require insulation, and 2 have fiberglass, and 3 have mineral wool insulation. Most of these assemblies are rated under 100% design load, but there is one assembly that's limited to 78% of the design load, and this is simply because the fire resistance test for this assembly was performed under a load that represents 78% of current design values. The assembly that's shown here is that's assembly WS4-1.2, which is framed with 2x4s at 16 inches on center, and it has mineral wool insulation. The 2-hour wall assembly described in DCA3 has 2x6 studs at 24 inches on center. It has mineral wool insulation and 2 layers of 5/8 inch Type X gypsum wallboard on each side. Since this is a symmetrical assembly, the 2-hour fire resistance rating can be applied to exposure from either side, of course. And as with most of the other wall assemblies described in DCA3, it's also rated under 100% of the design load. Now let's talk about the floor ceiling assemblies. Table 3 of DCA3 provides a summary of the 1-hour floor ceiling assemblies, and there are a total of 7 of these 1-hour assemblies, floor ceiling assemblies that is, in DCA3. Spacing, minimum flange depth, minimum flange area, minimum width thickness, and minimum depth of the framing members are all variables that are encompassed within this table. This includes a variety of single layer and double layer assemblies, most of which have steel furring, or in other words, the ceiling membrane is attached to either a steel hat channel or a resilient channel, which in turn is attached to the bottom flanges of the framing members. And just as with tables 1 and 2, which list the wall assemblies, table 3 includes links which take the reader directly to the more detailed descriptions of each individual floor ceiling assembly. Here's a zoomed in excerpt from table 3, which summarizes the 1-hour fire resistance rated floor ceiling assemblies, and it provides the same level of detail and information as is provided in tables 1 and 2 for wall assemblies, but of course there are a few more additional columns in this table because floor ceiling assemblies typically contain more components, like furring strips, for example, that are not included in wall assemblies. 4 of these 1-hour floor ceiling assemblies are what we call single layer assemblies, and this simply means that they have a single one layer of gypsum board making up the ceiling membrane. And all of them have I-joist framing at 24 inches on center. They utilize resilient channels or hat channels and have mineral wool insulation within the framing cavities. All of the single layer assemblies, that is, the single layer 1-hour assemblies. And then there are 3 1-hour assemblies that utilize 2 layers of gypsum wallboard, and so they'd have a double layer membrane. Since these assemblies have 2 layers of gypsum board, they're only rated for 1 hour as opposed to 2. They all utilize 1/2-inch gypsum board. The I-joist framing members are spaced at a maximum of 24 inches on center in these assemblies, and these double layer assemblies vary somewhat with respect to the presence of insulation and steel furring. The 2-hour floor ceiling assembly is described in Table 4. Aside from being the only 2-hour fire resistance rated floor ceiling assembly that's in DCA 3, it is unique in that it requires 3 layers of 5/8-inch gypsum board. Steel furring is used between the base layer and the middle layer of gypsum board, and fiberglass insulation is used between the framing members. Just as with all the other floor ceiling assemblies within DCA 3, this 2-hour rated floor ceiling assembly has I-joist framing at 24 inches on center, and it's rated at 100% of its design load. A number of optional variations are also mentioned within DCA 3 for these floor ceiling assemblies. These include options for floor toppings, framing and insulation variations, and floor coverings, different floor coverings. Floor topping options include normal weight or lightweight concrete, gypsum concrete, or no topping at all. And framing options allow for variations in joist spacing up to 24 inches on center and any joist depth, flange size, and web thickness greater than or equal to the specified minimums that are given in the applicable tables. Any code permitted floor covering can be used on top of the assembly, and any insulation thickness greater than or equal to the specified minimums can be used. The optional variations I've mentioned here apply to all of the floor ceiling assemblies described in DCA 3, but there are also some other options which apply to specific assemblies. The fire resistance ratings of these assemblies still apply if any combination of these allowable variations is made. Now, as I mentioned briefly earlier, DCA 3 provides not only fire resistance ratings, but it also provides sound transmission ratings for the floor ceiling assemblies. And just to remind you of what Ed said earlier about building code requirements regarding sound transmission, IBC section 1206 sets the minimum performance requirements for sound transmission of assemblies that separate dwelling units or that separate dwelling units from public areas. And compliance with these minimum sound rating requirements can be demonstrated through a couple of different avenues. Firstly, testing can be performed in accordance with ASTM E90 and E492. Secondly, engineering analysis based on comparisons to data from these tests that I just mentioned can be performed. So it can be either testing directly or engineering analysis. And then there's also a third option that allows for, of course, alternative methods that are allowed under IBC section 104. The sound rating data given in DCA 3 were established by a combination of both of the code allowed methods that are provided in IBC section 1206. So some of the sound rating data was derived directly from testing in accordance with the code reference ASTM standards that I just mentioned. And then other sound rating data was determined through engineering analysis based on comparisons to data from tests performed on similar assemblies. Therefore, wherever sound ratings are given in DCA 3, wherever they're greater than or equal to the code minimum of 50, either 50 STC or 50 IIC, these values can then be used to demonstrate compliance with that code requirement. Although DCA 3 does not currently give sound rating data for wall assemblies, it does give sound ratings for the floor ceiling assemblies. And because these are floor ceiling assemblies, they require both STC and IIC values, and both of these sets of values are given for the floor ceiling assemblies within DCA 3. These sound ratings are provided for various configurations of each assembly, which correspond to some of the optional variations that I mentioned earlier when I was discussing the fire resistance ratings. Most of the estimated values were determined using the AWC sound transmission model, which is presented in AWC's Technical Report 15 or TR15. And just like our other design guidance documents, TR15 is also available for free viewing on the AWC website. The rest of the sound ratings were obtained through laboratory testing. The rest of the sound ratings that are reported in DCA3, that is. Before I turn it back over to Ed, I just wanted to show an example excerpt of one of the sound rating tables in DCA3. A table like this is provided for each one of the 8 floor ceiling assemblies given in DCA3. As you can see in this table, STC and IIC values are given for variations of each assembly, both with and without a gypsum concrete topping. And by the way, toppings like gypsum concrete and normal weight concrete can really improve sound ratings, especially for STC. So these toppings are often used to achieve specified sound ratings that might not otherwise be attainable for certain light frame assemblies, like the ones covered in DCA3. Values for 2 different floor covering types are also given. Specifically, these are cushioned vinyl and carpet and pad, and these serve as representative floor coverings that yield very different IIC values. So they somewhat envelope the practical range of values for various floor coverings on that given assembly. And then the last assembly variation for which sound ratings are provided is joist spacing. Ratings are given for both 24-inch on center and 16-inch on center joist spacings. All of the fire resistance ratings in DCA3 correspond to a maximum joist spacing of 24 inches, but lesser joist spacings, of course, are also allowed. So assemblies with this variation, they can also still achieve the corresponding fire resistance rating that's given for that assembly. But you can see how greater joist spacings tend to yield slightly increased STC and IIC values. Now I'll turn it back over to Ed one more time so he can tell us about code requirements specific to Type 3 construction.
Thanks, Jason. Next, we're going to talk about Type 3 construction. The DCA3 can be used to help out in a somewhat tricky situation in platform construction of Type 3, where an exterior wall and a floor intersect. But before we look at that, let's take a closer look at just Type 3 construction in general. As you look at these pictures, these types of buildings in downtown areas of towns and cities across the country were at one time typically called ordinary construction. This referred to buildings with masonry exterior walls and interior structures of heavy timber or wood frame. Buildings like these were really the prototypes for what would be described as Type 3 construction in the legacy model codes. These buildings were often very close together, often sharing party walls between them. This is why we have that requirement for a 2-hour non-combustible exterior wall. That was there to prevent or slow down the spread of fire between downtown buildings. Early code writers knew the performance of these buildings and sought to assign them their own construction type, which still survives today as Type 3 construction. So here's a description of Type 3 as it reads in the code today. The Type 3 construction is a type of construction in which the exterior walls are of non-combustible materials and the interior building elements are of any material permitted by the code. The next sentence in there, though, is the one that we want to focus in on for as it relates to the DCA3. Fire retardant treated wood framing and sheathing, complying with section 2303.2, shall be permitted within exterior wall assemblies of a 2-hour rating or less. So here's table 601. We did look at this earlier, but as we look at Type 3 construction, we look at the bearing walls on the exterior and non-load bearing walls on the exterior as well. You can see that the exterior bearing walls require a 2-hour fire resistance rating, and that the non-load bearing exterior walls actually sends you over to table 705.5. Now you may notice that there's some footnotes in the bearing walls on the exterior, footnotes E and F. Those are also basically going to refer you over to table 705.5. We talked about 705.5 earlier, but we didn't actually look at it. So let's take a look at it right now. Now again, this is based off the 2021 IBC. If you're still on a 2018 or earlier version of the IBC, you may recognize this table as table 602 in the code. The 2021 version moved it into chapter 7 into section 705.5. So these in the red boxes here are all the different instances where type 3 construction would come up based off of the fire separation distance. As you can see, it's typically 0, 1, or 2 hours. However, there is one box there with group H occupancy when you have a fire separation distance of less than 5 feet, where you actually would get into a 3-hour fire resistance rating on that exterior wall. And again, that would be for either load-bearing or non-load-bearing exterior walls. We talked about this earlier as well, but just to remind you, if you are 10 feet or less to a fire separation distance, which is typically going to be a property line, but it could also be an imaginary property line between two buildings, or also a separation to a public way or street. But if you are 10 feet or less to that fire separation distance, you do have to worry about fire not only originating on the inside of the building, but also originating outside of the building. So you need to have a fire resistance rating on that wall that's taking that fire exposure from both sides. Now here's a picture of our typical platform construction that I talked about early on in this presentation as what we're calling wood frame construction. But just to recap, exterior bearing walls in type 3 construction, they are required to have at least a 2-hour fire resistance rating, again, for the bearing walls. And that's out of table 601 in the IBC. And then if you're going to frame these out of wood, the sheathing and the framing members have to be fire retardant treated wood. And that comes out of IBC 602.3, which is the definition of type 3 construction. So as we look at platform construction, there's a couple different things that we want to look at. So first, you have structural stability of the exterior wall that's found in IBC 705.7, and then also structural or supporting construction found in 704.11. We'll take a look at each of these sections a little bit more in depth. So we'll start off with IBC 704.1, which talks about the fire resistance ratings of structural members in the assemblies shall comply with this section and the requirements of the type of construction as provided in table 601. We move down to supporting construction 704.1.1. The fire resistance ratings of supported structural members in assemblies shall not be less than the ratings required for the fire resistance rated assemblies supported by the structural members. So when you think about this, say that you have a floor that's required to be 2-hour fire resistance rated. If that floor is being held up by beams and columns underneath it that are only 1-hour fire resistance rated, well, after 1 hour of fire, the beams and the columns underneath that are supporting that 2-hour floor are potentially going to fail, which means that 2-hour floor will not be able to stay there for the full 2 hours. So what 704.11 is telling you is that any structural members underneath that's supporting that 2-hour floor would also have to be 2-hour fire resistance rated. So that beam and that column, even though table 601 may say you only need to have 1-hour rating on there, because you're supporting a 2-hour floor, you're also going to have to actually make that a 2-hour rated beam and column assembly then. Moving on along the code here, 705.7 talks about structural stability. So interior structural elements that brace the exterior wall but are not located within the plane of the exterior wall shall have the minimum fire resistance rated required in 601 for that structural element. So what that sentence is telling you is that if you have that exterior wall and you have an interior element that's bracing that exterior wall, but it's not within the plane of the wall, again, for example, a floor that would be coming in there and bracing that exterior wall, that floor would actually just follow the same fire resistance rating requirements that are found in table 601 for that floor. They don't have to have that same fire resistance rating of that exterior wall because they're just bracing it. They're not actually supporting the gravity loads of it. The next part of 705.7, structural elements that brace the exterior wall but are located outside of the exterior wall or within the plane of the exterior wall shall have the minimum fire resistance rated required in 601 and table 705.5 for the exterior wall. So now if you have something that's bracing that exterior wall on the outside, maybe a flying buttress, something like that, if that exterior wall is 2-hour rated, that buttress on the exterior of the wall also would have to be 2-hour rated. Similarly, anything that's within the plane of that exterior wall also has to have that same fire resistance rating. So now when we think back to platform construction, you're looking at the rim board or the rim joist that's going to be within the plane of that exterior wall. That rim board or rim joist, that's also going to have, for example, if you have a 2-hour exterior wall, that rim board or rim joist would also have to be 2-hour rated. Now the floor, that's an interior element, that's not within the plane of that exterior wall. So that's still going to have whatever fire resistance rating is required of a floor in table 601, because that's just coming up there and bracing that wall. But what's actually supporting the exterior wall would be that rim board or rim joist. We'll see this again quite a bit in the DCA 3. Now I'll take you into the 2024 IBC a little bit just to show you the next step in what's coming down the road for the codes here. So table 70571 is a new code section in the 2024 IBC, so not many people have this adopted yet, but it does really address what we're trying to talk about in the DCA 3 and also in the ICC commentary. It's going to talk about focusing on that rim board and rim joists that are out there, and then also contributing from the ceiling membrane. So let's take a look at, again, this is out of the 2024 IBC, but this is section 70571, and this talks about floor assemblies in type 3 construction. So in type 3 construction, where a floor assembly supports gravity loads from an exterior wall, the fire resistance rating of the portion of the floor that supports the exterior wall shall not be less than the fire resistance rating required for the exterior wall in table 601. So this is really just what we were talking about in 7057, right? The rim board or the rim joist is the portion of that floor assembly that's actually supporting that exterior wall. So that's going to need to have the same fire resistance rating as the exterior wall. It does not have the fire resistance rating of the floor. The next sentence down, the fire resistance rating provided by the portion of the floor assembly supporting and within the plane of the exterior wall shall be permitted to include the contribution of the ceiling membrane when considering exposure to fire from the inside. Now, when Jason goes through some of these details in the DCA 3, you're going to see how this actually plays out. But basically what that's saying is now, if you do have, for example, a 1-hour rated floor, that's going to have, at least probably one layer or a couple layers of some gypsum protection on the underside of that floor assembly. Well, you can use that to provide some of that fire resistance rating of the rim board or the rim joist that we're trying to protect in there. Again, that rim board or that rim joist, that's going to have the same fire resistance rating as the exterior wall. So if you just put that in there by itself, you can actually use some of that ceiling membrane as part of the protection for that rim board or that rim joist. The last part of 70571, where a floor assembly supports gravity loads from an exterior wall, the building elements of the floor construction within the plane of the exterior wall, including but not limited to rim joists, rim boards, and blocking, shall be in accordance with the requirements for interior building elements of type 3 construction. So again, we talked about how when you're building with wood in type 3 construction, your exterior walls have to be made out of fire retardant treated wood, FRTW. What this section right here is saying is that that rim board, that rim joist, that blocking that's within the plane of that exterior wall are still considered part of the floor. So they're still part of the interior building elements. They can be made out of anything in the code. They're not confined to that FRTW requirements of the actual exterior wall. So it's still considered an interior building element, but it also has to have that exact same fire resistance rating as the exterior wall. So that's the code in the 24, and previously we just talked about what's in the 21. It's still the 2021 code still says the same thing. It's just gotten a lot more clear in the 2024 code. We added in a little bit more language here to to really make sure that people understood what all was going on inside of that intersection between the exterior wall and the floor construction. With that, I'm going to turn this back over to Jason, who's going to actually show you how this all gets applied then into the DCA3.
Thanks, Ed. Well, I'll go ahead and wrap us up with these final few slides here. And as I mentioned at the beginning of this webinar, in addition to describing fire resistance rated assemblies, DCA3 also provides some example exterior wall floor intersection details that are in compliance with the code provisions that Ed just went over for us. Firstly, I wanted to reiterate that these details apply specifically to Type 3 platform construction, in which wood framing members are used in the exterior walls. The primary objective that they're intended to fulfill is to provide details that will ensure continuity of fire resistance rating through the floor from the wall above to the wall below. And then a secondary objective of these details is to identify which framing members within these intersections are required to be fire retardant treated in accordance with the building code and which ones are not. In these example details, the continuity of the code specified 2-hour fire resistance rating is established through calculations in accordance with IBC section 722, which references chapter 16 of the National Design Specification for Wood Construction, NDS. And the NDS in turn references the FDS, or Fire Design Specification, for certain aspects of fire design which are not covered within the NDS. Also, as stated in section 705.7.1 of the 2024 IBC, the contribution of the sealing membrane is permitted to be accounted for as protection to the load-carrying rim board, or whatever the load-carrying member is that transmits load from the wall above through the floor ceiling assembly to the wall below. And these example details in DCA3 do just that. They help to ensure, they provide examples of how that intersection can be detailed to ensure continuity of fire resistance rating through that intersection, from the wall above through the floor ceiling assembly to the wall below. The primary design objective, like I said, behind the example interior wall floor intersection details is to ensure that that load-carrying rim board is protected from fire exposure for the full 2-hour fire resistance rating period that's required in order to provide that continuity that I just mentioned. And this is not because the rim board is considered to be part of the exterior wall. It's not. IBC section 705.7.1 makes it clear that the rim board is part of the floor assembly, not the wall assembly. Rather, it's to comply with IBC section 705.6, the load-carrying rim board requires 2 hours worth of protection in order to ensure that continuity of that fire resistance rating that's required for the exterior walls is provided between the exterior wall of the story above and the exterior wall of the story below. These example exterior wall floor intersection details in DCA3 show configurations that rely on protective wood cover and also layers of fire resistance rated or fire rated gypsum, type X gypsum, and in some cases some of the details rely also on mineral wool insulation within the floor ceiling assembly. All of these combined to provide the required level of protection to the load carrying member, which in these details is the rim board within the floor ceiling assembly. The protection provided by the wood blocking is calculated in accordance with FDS provisions for protection provided by wood cover. For example, a single layer of 2x nominal wood blocking having a thickness of 1.5 inches would provide approximately 1 hour of protection to the load carrying rim board behind the wood blocking. And a sealing membrane consisting of 2 layers of 5/8 inch type X, as an example, would provide approximately 80 minutes of protection to the load carrying rim board. That's 40 minutes per layer. So what side is the fire exposure assumed to come from? Well, as Ed mentioned in his last segment there that he just presented, IBC section 705.5 states that where the fire separation distance is greater than 10 feet, the fire resistance rating of the exterior wall assembly applies only to exposure from the interior side of the building. Such an exposure is depicted here, and the resulting design of the protection that would be necessary would need to account for the exposure from the interior of the building only. This is where the contribution of protection from the ceiling membrane comes into play. Added to this protection from any wood members that cover the load-carrying rim board would be the contribution from the ceiling membrane. In this example, there's blocking, which is shaded green here, to serve this purpose. And then where the fire separation distance is less than or equal to 10 feet, IBC section 705.5 states that the fire resistance rating of the exterior wall assembly applies to exposure from both the interior side and the exterior side of the building. On this slide, the diagram on the left depicts exposure from the exterior, and the diagram on the right depicts exposure from the interior. That one on the right is the same as the one that I just showed on the previous slide. So where the fire separation distance is less than or equal to 10 feet, exposure from both directions needs to be addressed, and that's separately, of course, not simultaneously. In the previous slide, I already described how protection of the load-carrying rim board can be achieved when exposed to fire from the interior of the building, as shown on the diagram on the right. But then the diagram on the left considers protection from fire exposure on the exterior side of the building. In this scenario, the blocking would serve as the load-carrying element. So the blocking is the member that is not depicted in green there on the diagram on the left. And you can see that protection of the load-carrying blocking is provided by a combination of the rim board, which is shaded green in the diagram on the left, and layers of membrane to the exterior of the rim board. And these membranes may consist of a combination of fire retardant treated wood structural panels and perhaps exterior gypsum sheathing as well. Here's an enlarged excerpt of one of the example wall floor intersection details in DCA 3. And this one is an example in which both the rim board and the blocking are used. As I alluded to a minute ago, when exposed to fire from the interior, the wood blocking and the ceiling membrane provide protection to the rim board, which transmits the load from the wall above to the wall below. And then when exposed from the exterior, a combination of the exterior fire protection, FRTW sheathing, and that's fire retardant treated wood sheathing, and the rim board are combined. They provide a combined 2 hours of protection to the blocking. And the blocking would carry the load in that case when you're considering exposure from the exterior. So this second detail is also from DCA 3, and it differs from the first one in that it presents a case in which there are two rim board members side by side rather than one rim board and then blocking to the interior of that. But other than that, this detail and the rationale behind it are the same as the first one that I just presented. It's not shown on these excerpts, but each of these example details is also accompanied with explanations of how the fire resistance rating is achieved from the interior side, and then also, if necessary, from the exterior side. Here's the third example in DCA 3, and these details within DCA 3, which presents a case in which there is one rim board and no blocking. So in this example, the rim board would have to be fairly thick in order to still support the load even after loss of some section due to charring. These first three examples, they deal with type 3A construction, in which the floor ceiling assembly is required to have a 1 hour fire resistance rating. So you can count on some of the protection from the ceiling membrane. As you can see in this diagram, there are three different cases presented here. Each of these cases correspond to a different ceiling membrane configuration. The idea is that since the ceiling membrane provides a certain amount of protection to the wall floor intersection, this will affect how much fire resistance is required of the blocking or rim board that would be protecting the load carrying member. And of course this applies to exposure from the interior. These different cases are referred to as cases A, B, and C, and you can see them there on the lower right of this detail here. And each case corresponds to a different required minimum rim board thickness because they have differing contributions from the sealing membrane. Basically, if there's less protection provided by the sealing membrane, this has to be compensated by additional thickness in the rim board. That's what it boils down to. And this allows the continuity of the 2-hour fire resistance rating to be maintained. And then the fourth and last example detail that's in DCA 3 is different from the first three, and that's because this is for type 3B construction. And of course, in type 3B construction, the floor ceiling assembly doesn't need to have a fire resistance rating, so it's assumed that no protection, and this is probably a conservative assumption, but it's assumed that there's no protection from the sealing membrane in this diagram here, in this example. So the blocking needs to be thicker in order to provide protection to the load carrying rim board for the full 2 hours of that fire resistance rating period. And that's why in this example you see 2 layers of blocking depicted, and that's to provide that necessary required thickness. And briefly, before I conclude, I wanted to point out that each of these figures indicates which of the wood members are required to be fire retardant treated. The requirement for using fire retardant treated wood in exterior walls of type 3 construction is intended to address the potential for flame spread on or within the exterior walls. And it's important to note, though, that the use of fire retardant treated wood in lieu of untreated wood does not necessarily increase or decrease the fire resistance rating of the walls. Fire retardant treated wood addresses flame spread, but not necessarily fire resistance ratings. According to IBC section 602.3, in type 3 construction, all of the sheathing and framing members in the exterior walls are required to be fire retardant treated if wood members are used there. So you can see that the sheathing and framing members in the walls are colored red here, and that's meant to signify everything that's colored red is something that would need to be fire retardant treated wood. And then those members that are not colored red are not required to be fire retardant treated wood in accordance with the code. There is no code requirement for the sheathing and framing members of the floor to be fire retardant treated, so that's why they're not shaded red there. And the fact that I wanted to point out that the fact that the rim board is considered to be part of the floor rather than the wall, and the floor, of course, is an interior building element. That's as stated in 705.7.1. This is now clarified in the 2024 IBC, section 705.7.1. Well, that concludes our presentation today, and I wanted to thank you all for joining us, and I look forward to answering any questions if we have time now. Look forward to seeing you next time as well. Thank you.